This is my second video covering 5.3. In the first video for this section, I went over how to find restrictions on variables, specifically when we're dealing with radical equations. And in this video and the next one, I'm going to be going over how to actually solve radical equations. So let's dive straight into it. So what is a radical equation? That's a pretty important thing to understand before you start solving them. Thankfully, it's a pretty straightforward concept. A radical equation is an equation that has a radical in it. But specifically, a radical that has a variable. So you can have a root 2 and it's not a radical equation, but the moment there's a root x, then that is a radical equation and we do have to deal with it appropriately. So a radical involving a variable. And that could be a very complicated equation with lots of things going on, might even have more than one root in it, or it can be really simple like the first few we're going to do here. So let's say you were asked to solve the square root of x equals 4. Well, you don't really need to know any specific things to get this, because you can probably just look at this and figure out what the number is. But in general, our process is going to be something on the lines of we need to figure out what the root equals, and then we need to figure out what the variable inside the root equals. So we're going to start with this one by getting rid of the root, because that's how we need to isolate our variable. And so to get rid of a root, which is something you've probably done before, we need to do the opposite, which is squaring. So we're going to square both sides. So in our case, that means we've got, again, square root of x equals 4. We're going to square both sides of this equation. And so when we square a square root, we just end up with the variable again. And then when we square that 4, we're going to get 16. And there we go, we're done. X equals 16, which makes sense, right? The square root of 16 does equal 4. The one main thing to take away from this particular question, though, is that after you've finished solving in this unit, so after we solve, after we get that x value, there's two things we have to do every single time. First, we have to look at those restrictions that we talked about in the last video. So we're going to have to go through the process, figure out what they are, and make sure our solution fits those restrictions. And then second, we need to actually check our solution to make sure it works, because there are going to be some cases in this chapter where we're going to find some solutions, and even though they look like they work, they actually won't. So we'll talk about that once the situation arises. For now, let's look at this particular equation, figure out what our restrictions are, and check our answer. So, remember, to do restrictions, we take our radicand, which in this case is just x. We set it greater than or equal to 0, and we would solve if there was any solving that needs to happen, but in this case, that's that. And our solution, 4, does work here, right? 4 is bigger than 0. And now we're going to check our solution. So we've got the square root of x equals 4. We plug in that 16, so the square root of 16 equals 4, and the square root of 16 is 4, so that's all good. 4 does equal 4. We're happy. So let's try another one. We're going to solve the square root of 3x plus 4 equals 7. So there's a little bit more going on here, a little bit more that we're going to have to be aware of. So we've got the square root, 3x plus 4 equals 7. Same sort of idea as last time. We're going to start by squaring both sides to get rid of that root. And so we get 3x plus 4 equals 49. Key thing to remember, when you square the root, nothing happens to the radicand, so that 3x plus 4 doesn't get multiplied by anything. It doesn't get FOILed by anything. It just stays as 3x plus 4. And so now we just have a basic equation to solve. We're going to subtract 4 from both sides, which we get as 3x equals 45. We're going to divide by 3, again on both sides, and that's going to get me that x is 15. Okay, so I have solved. Now we have to do those 2 extra steps and find our restrictions and check our solution. The restriction is a little bit more complex this time. So again, we take our radicand, 3x plus 4. We set it to greater than or equal to 0. We're going to subtract 4 on both sides, which will get me 3x is greater than or equal to negative 4. We're going to divide by 3. And we get our final restriction of x has to be greater than or equal to negative 4 over 3, which 15 definitely is. So we're all good there. Then we need to check our solution. So we're going to go back to our equation, and we're going to plug 15 in for x. And we're just going to check. One key thing to note here, a place a lot of people tend to go wrong. You are not solving this. You are not doing opposite operations. You're not going to try to get rid of this root. You're not going to square both sides. Imagine there's a wall here, and nothing gets past this wall. You are not doing things on both sides of this equation. You're not moving things around. You're just calculating. You're following your basic bed mass. You're calculating an answer, and then you're just going to make sure if that answer compares with something else. So in this case, we're going to do 3 times 15. We're going to get 45. We're going to do 45 plus 4 and get 49. And then the square root of 49 is 7. And that matches the 7 that we had on the other side of the equation. So we're not trying to solve for anything. We're not trying to isolate anything. We're just calculating both sides of our equation to make sure they are the same. So this one's good. And so our solution works. We're happy. Let's make it a little bit more difficult, though. So say we had some stuff outside of the root, which we haven't dealt with yet. That is going to make this a little bit more complex. So we want to isolate that x eventually, but there's a lot of things that need to happen before we get that far. Really key to note, when you're solving equations like we're doing here, you're not following bedmass because you're not doing operations, you're undoing them. So the same thing we talked about way back when we were solving by completing the square, same principles apply here. We're going to follow SAMDEB instead. And if you remember your exponents unit back in Math 10, you might remember that roots are actually just exponents written in a different way. So our root is going to get dealt with here. So we'll worry about that later. For now, what I need to tell you, the key thing to remember when you're solving these things is you're going to start not by isolating your variable, but by isolating the root. Once we've got the root isolated, then we can worry about everything else. But you really need to start by isolating your root. And that sometimes will be harder than in other cases, but we'll deal with some harder stuff in the next video. For now, let's just focus on basics. So we've got 2 root x plus 3 minus 4 equals 8. And so if we're thinking SAMDEB, right, we're going to start with subtraction and addition. So that's that minus 4. So we're going to add 4 on both sides, which is going to get me 2 root x plus 3 equals 12. Then this is where a lot of people tend to go wrong. Some people leave that 2 there, and you definitely don't want to leave that 2. So we're going to divide both sides by 2 as well, which is going to get me root x plus 3 equals 6. And now we've isolated our root. So now we can square both sides to get rid of it. So we're going to square both sides of our equation. We're going to get x plus 3 equals 36. And now we can isolate our root. So we're going to subtract 3 on both sides. And we're going to get our final answer of x equals 33. Which, well, we'll find out if it works. So let's do our restrictions. We've got a pretty simple one in this case. X plus 3 is greater than or equal to 0. We're going to subtract 3 on both sides. And we just get x is greater than or equal to negative 3. Again, 33 is totally fine. We're going to check our answer. So we've got 2 root 33 plus 3 minus 4 equals 8. And so this is what I was talking about. We are not going to start moving that 4 to the other side. We're not going to divide by 2. We're going to just completely ignore this equals 8 for now. We're going to pretend it's not there, and I'll come back to it later. So on the left side of my equation, 33 plus 3 gets me 36, which gets me here. The square root of 36 is 6. 2 times 6 is 12, and 12 minus 4 is 8. And so all of that has worked out to equal the other side of this equation, and so we're happy. This thing balances out. It's all good. The reason that we can't move stuff around will come up later when we get into some of the cases where we don't have solutions that actually work. So for now, just take my word for it. All right, we're going to wrap this up with one last example. This one's for you to try. It's going to be a little bit tougher, not a lot, but just a little bit more going on. So try this one out. Be really careful with your negatives here, because that's how this one's really going to catch you if you're not paying attention. Come back and see how you did once you're done. All right, so Sam Deb, right? We want to start by moving not the 7. So the temptation there is to say, okay, 5 minus 7, get rid of the 7. But the 7's a coefficient. We can't deal with that first. The first thing we actually have to deal with is the 5. So we're going to subtract 5 on both sides, not add 5. And we're going to get negative 7. Don't forget that negative. Gets us 4 minus x, and then equals negative 14. Now we can deal with the negative 7. So we're going to divide both sides by negative 7, not positive 7, which is going to get me 4 minus x equals 2. Now we can get rid of that root, so we're going to square both sides. So we get 4 minus x equals 4. And so now we want to solve and isolate our variable. So we're going to subtract 4 on both sides, which is going to get me negative x equals 0. And, well, we don't want negative x, so let's get rid of that negative, divide both sides by negative 1, and we get x is, well, it's still 0, because 0 divided by negative 1 doesn't change. And so that might seem weird to you. Some people get a little confused when the answer is 0. 0 is just a number. It's totally fine. So let's do our restrictions. We've got 4 minus x is greater than or equal to 0. We're going to subtract 4 on both sides, which gets me negative x is greater than or equal to negative 4. And now when we divide by negative 1, that is actually going to do something. We're going to get x, and we're going to get 4. And remember, you're going to flip that inequality because you divided by a negative number. So this gets us that x has to be less than or equal to 4. Or you could have done that a slightly different way. You could have also, if you had 4 minus x greater than or equal to 0, you might have started by just adding x on both sides, which would get you that 4 is greater than or equal to x, which works out to the same thing. So you can be strategic about it, move things in ways that make things a little bit easier. It's up to you. Now we check our solution. So we've got 5 minus 7 times the root of 4 minus our solution, which was 0, equals negative 9. Well, 4 minus 0 is just 4. And the square root of 4 is 2. And then 7 times 2 is 14. And 5 minus 14 does, in fact, equal negative 9. So we got a solution that works. So there's your intro into solving radical equations. In the next video for this, we're going to go into cases where maybe the solutions don't work out, or cases where the solutions are going to be a little bit more complicated to solve. So make sure you've got a handle on this, then move on to the more advanced topics for the next video.